Please welcome Larry Ellison.
Okay, on Sunday, I announced the Oracle Autonomous Database, the world's first completely self-driving database. And today, I'm going to talk about our new cyber defense system, the Oracle Management and Security Cloud. And while the database is 100% automated, it's completely self-driving, it's autonomous, we're not quite there yet on our cyber defense system. It's highly automated, it has a huge amount of automation, it's more automated than anything else, but it's not 100% autonomous. So it really does work in conjunction with human beings to protect your data. And these two systems, the Oracle Autonomous Database and our highly automated cyber defense systems, are designed to stop data theft. And they work together to do just that. Companies are losing the cyber war. And it gets worse every year. Equifax is now in the news, where 143 million records, or records for 143 million Americans, it's about half of us, were stolen from Equifax. By the way, it's not just Americans, they're Canadians and Brits, but the American portion of the loss was 143 million. And they stole credit card data, social security data, home address data. I mean, it was a serious loss of information. And interestingly enough, all that data didn't show up on the dark web for sale the following day. It looks like it was stolen by a state actor who have other uses for the data. But think about it. Companies have to defend themselves against nation states who are stealing their data, and very sophisticated cyber criminals who are stealing their data. This is not an easy task to defend yourself against nation states. Some of these guys are very good at what they do. Equifax, apparently, according to congressional testimony, and that's what's going on right now, they've been called before Congress to testify and explain what happened. This is very, very embarrassing. This is headline data. Pretty much the entire executive team was forced to resign. The entire senior IT team was forced to resign. And that's just the beginning. The SEC is investigating stock sales that occurred after the hack and data theft, but before it was announced publicly. I mean, this is really a very bad situation. So, what can we do about it? Well, we have to reprioritize and rethink about how we defend our information. We need new systems. It can't be our people versus their computers. We're going to lose that war. It's got to be our computers versus their computers. And make no mistake, it's a war. Equifax, I don't think, was the worst loss that I've read about. And I can talk about what's in the news. And the Office of Personnel Management said, oh, how bad could that be? Office of Personnel Management, a federal agency, lost the records of 20 million federal employees. Oh, okay. How is that any worse than the Equifax loss? Well, these were people who had security clearances. and all of their security clearance and background data was stolen. These are the people who work at the White House and the Defense Department and the State Department and our embassies overseas. This was another state actor who took this data. And suddenly, the state actor knows everything about every employee who works in the embassy in their capital city and the consulates in other cities around the country and around the world. And we had to pull, from if what I read in the newspaper is true, we had to pull a lot of our agents, a lot of our intelligence agents out of the field because of this. This was an extraordinarily serious data loss. We are losing the cyber war. And our adversaries, the people we're fighting against, aren't our normal competitors. If you're a grocery store, you have a new competitor. It's Amazon, Whole Foods. You don't really think about your competitor being a nation in Eastern Europe who's stealing all your information. But they're a competitor also, or at least an adversary. We've got to do something. The current strategy is not working. The current strategy of some log analytics, looking at some logs, and some people patching some systems as best they can when there's a downtime window to do the patch is not working. One of the things that happened at Equifax was once they realized there was a vulnerability in Apache struts, by the way, nothing wrong with using open source software as long as you manage it properly. They were using Apache struts, and they said, okay, there's a problem, there's a vulnerability, we got to patch it. They couldn't even find all of their instances of Apache struts. They didn't have a tool set that allowed them to keep track of all of their assets in their data center so they could find every place they use Apache struts and patch it. They couldn't find it. Our data centers are enormously complicated. There are lots of servers and storage and operating systems, virtual machines, containers, databases, data stores, file systems. And there are thousands of them, tens of thousands, hundreds of thousands of them. It's hard for people to locate all these things and patch them. They have to be aware there's a vulnerability. It's got to be an automated process. You can't wait for a downtime window where you say, well, I can't take the system down. I know I got to patch this, but we have scheduled downtime middle of next month. Well, that's wrong thinking, and that's kind of a lack of priority for security. All right, maybe the most interesting thing I'll say, at least from my point of view, I'm going to say right now for this thing is, we don't take the security threat terribly seriously. Other people, or very few people in our organization, take it seriously. The people who are focused on security take it very seriously. The people who have other jobs in the data center are trying to get their jobs done. And sometimes when there's a security audit, they say, well, no, you're just slowing me down. You're slowing me down. I can't do all this stuff. So we've got to provide security without slowing down our other tasks. But we have to elevate the priority of security in our data center. Because no one wants to be on the front page about having lost their company's data. Equifax is a 100-year-old company, and they're fighting for their survival. Because someone in the data center didn't locate an instance of Apache struts and fix it when a fix was available. I had an experience with I'm not going to be terribly specific, with a European defense contractor, a very large European defense contractor that was acquiring a system. And I got into discussions with this very large European defense contractor, and one of the things, late in the game, I said, there are security issues. Look, I'm not even trying to sell our system. They're requiring a human, an HR system, if you will, an automated HR system. I said, I don't want to sell you anything. I'm just telling you, before you acquire what you're planning on acquiring, you should look at all the security vulnerabilities in the system you're looking at. And make a long story short, their reaction was, well, the HR team is making that decision. They like this system. We don't think it's any worse than what we already have. This was a defense contractor, a gigantic defense contractor with all of their HR data in the European Union. Our priorities are wrong. This security is a big deal. In aviation, safety is a very big deal. We just don't tolerate airplane crashes. We really don't. And there are very few airplane crashes. We've made safety kind of, job one. Ford said quality is job one. Aviation safety is job one. Security in our data centers, I don't know, what is it, job 10? It's really not prioritized, and I think we have to rethink about that. Okay. All right, more automation. The way to secure our data, to prevent data theft is more automation. And we need a cyber defense system that automatically detects vulnerabilities and attacks. Vulnerabilities, fix the vulnerability before an attack, and then if there is an attack, detect the attack and shut it down. The other thing is to automatically detect an attack or automatically detect a vulnerability is one thing. We're looking at a bunch of database instances, and we find a database instance that, for some reason, doesn't have these 4 security patches. One of the things you do in automated security, and I'll talk about that, you look at kind of what a normal database instance looks like. You scan all this data, and all my instances of the database have all of these security patches. Whoa, wait a second, here's one over here that is missing 4 security patches. You should detect that long before an attack, because this configuration is so different from all your other configurations, and then you need to automatically fix it. You shouldn't have to. There should be no human intervention, and there should be no downtime required. It needs to be fully automated. To do that, we built the autonomous database that automatically will patch itself while running. These two systems, the detection system and the remediation system, work together. Again, it can't require manual intervention. Human beings make mistakes. My autopilot, my airplane flies way better than I do. When we go to autonomous cars, it's not that accidents will disappear completely, but we'll have fewer accidents, a lot fewer accidents than with human drivers. Autopilots are safer than human drivers. Autonomous database is much less likely to make a mistake. I'm not saying it's never going to make a mistake, but it's much less likely to make a mistake than a team of human beings managing that system. And not only do you have to patch yourself while running, you have to have other capabilities, like you have ransomware that deletes information from your system. Somehow it gets through. It could be an inside job. It could be an internal user that maliciously deletes a lot of your data. You've got to be able to go back. Your system has to be able to recover from those kind of failures. So you want to prevent attacks. You want to identify vulnerabilities and fix the vulnerabilities before there is an attack. You want to identify attacks and stop them when they're occurring. And then if an attack is successful and data is deleted, you need to recover it. Check, check, check. All three done by the Oracle Autonomous Database. More automation means higher security, but you've got to be willing to pay less. Autonomous cars, if an autonomous Uber picks you up, the autonomous Uber is going to be way less expensive than the Uber with the driver. Automation costs less. Automated security does a better job and costs less than manual security. All of this, the autonomous database and our automated security system, is based on a new technology called machine learning. Machine learning is the most important new technology to show up for a long time. It kind of is delivering the promise of artificial intelligence when the idea of AI was first discussed and early systems were built. It never kind of lived up to its promise until now. Machine learning actually works. I'm not going to spend a lot of time going into how it works. I am going to have a couple slides on it. But the applications for machine learning are as charismatic as anything that's happening in our world today. Self-driving cars, fully autonomous cars. The computer that when you walk up to it right now, you don't have to touch anything, no fingerprint, it just recognizes your face and lets you log on. Computers are now better at distinguishing a person's face than people are. People are more likely to mistake somebody for someone else than a computer is. Computers are very good at this. I think I mentioned on Sunday, there's a city in China that knows every single person, knows their face, knows where they are, knows where, when they're crossing a street, know if they're crossing on a red, a yellow, or a green. Back up one slide, please. And using the same technology, machine learning that is the foundation of self-driving cars, the foundation of facial recognition, we have taken that machine learning technology and we're applying it in two new areas. One, to build the autonomous database I described on Sunday, and two, to build our highly automated security and compliance cloud. Machine learning simply means that machines looking at lots and lots of data, the more data they look at, the smarter they get. Specifically, they can distinguish certain patterns in the data. They start to be able to look at certain patterns in the data, and they can distinguish normal patterns in the data from abnormal patterns in the data. And we actually say you're training, the more data we have these computer systems look at, we say we're training the computer system. And as the computers begin to identify patterns in the data, identify abnormalities in the data, they then can make predictions. The computers make predictions. And as we give the computers more and more data to train on, we say the computers are learning if and only if their predictions get more accurate. That's the test. We give it more training data, their predictions get more accurate. And one of the things computers can do now, they can look at cells and start to distinguish one kind of cell from another kind of cell. They can start to distinguish nerve cells of neurons from hepatic cells, liver cells. But they'll kind of cluster all the neurons over here. They kind of look alike. They cluster the hepatic cells over here. They kind of look alike. But then, so there are these patterns, and there are several different patterns that are all cells, all normal. And then they say, wait a second. This cell does not look like any of these other cells. It's an abnormality. And that's a cancer cell. So these computers get better and better at identifying anomalies in the data, abnormal patterns in the data. An abnormal cell, a cancer cell from a healthy cell. Also a very charismatic application for machine learning. And we use it in our security system to detect an abnormal event, like our chief financial officer. She logs on from her home in Atherton. And then she logs on from the Nobu restaurant in Palo Alto. And then she logs on from the Four Seasons Hotel in New York City. And then she logs on from a military base in the Ukraine. Either she's taking a really weird kind of holiday in Eastern Europe, or this is the problem. And we need to identify, and we separate, the machine learning separates that. That's a weird IP address, that's a weird URL, it's abnormal. We're going to log this as a security incident. That's what machine learning does. Looks at all of these logons, looks at all the IP addresses, URLs, distinguishes normal behavior from abnormal, risky behavior. Good news is, machine learning requires huge amounts of data to ingest and understand normal patterns and then detect anomalies. We have huge amounts of information about computer systems. We log everything. There are operating systems, Linux. There are lots of Linux logs. There are lots of VM logs. There are Docker container logs. There are database logs, Java logs, analytic systems. All the applications keep track of who logs in. The database keeps track of who logs in. The operating system keeps track of who logs in. We have we produce billions and billions of log records in our data center. And that information, that data can be used to train computers to say, this is normal, ignore 99.9999% of the data, but logging on in Ukraine in a military base, that's not normal. Certain kinds of SQL queries from that user, that's not normal. Identify those abnormal events. Looking at all these configurations over here, that's normal, that's normal, that's normal configuration. Wait a second. No one's security patched this system in 5 months, and someone turned off the audit log. That's not normal. Distinguish normal patterns from abnormal patterns. Okay, and we can then detect anomalous events, or like we do with the autonomous database, we can just understand normal query patterns and optimize query patterns and use the normal information to tune the database, automatically tune the database. Okay. 2 revolutionary new products at Oracle Corporation. One, Oracle 18c, the world's first autonomous, fully self-driving database. And 2, our new highly automated management and security system. Both of them use machine learning to detect attacks and stop them real time after detection. So the security system detects an anomaly, and the database automatically patches itself. Now on Sunday, by the way, autonomous database has a lot of other benefits in addition to patching, security patching, in addition to protecting against data theft. I discussed those on Sunday. I have one slide that kind of summarizes what we discussed on Sunday on the autonomous database. The autonomous database is autonomous. There is no human labor, zero human labor administering the database. The database automatically provisions itself, upgrades itself, patches itself, backs itself up, and tunes itself while running. It never goes down. And because there's no human intervention, there's no human error. Because there's no human error, we can guarantee, we will guarantee, it will only be down a maximum of 30 minutes a year. That's all downtime, planned downtime, unplanned downtime, fixing software bugs, upgrading to new major versions, security everything. We do all that online. We do all of that online. And because it's completely automated and there's no human intervention, there's no human error, and there's no opportunity for human malicious behavior. That's foreclosed. The other thing it does, because it's fully automated, I said one of the things that comes with automation, if you automate something, you've got to be willing to pay less. So we guarantee in our SLA, in our contract with all of our customers, that if they have an Oracle workload at Amazon and they move it to Oracle, we guarantee their Amazon bill will drop by at least 50% when you move to Oracle. And of course, the labor savings is even a bigger savings. But again, this happens with automation. With automation, it's much, much cheaper, much more reliable, much safer to run an automated system than a manual system. Anyway, we talked about that on Sunday. I'm going to stop right here and go back to security. All right, there's been a dramatic rise in breaches, outages, resulting in data theft. The biggest problem by far is data theft. No one wants outages. No one wants their system to be down. No one likes that. But the real problem is loss of information. If your system is down and you can't sell tickets or sell flashlights or whatever you're doing on your online system, that's not good. You'd like the system to be available all the time, but you don't get called in front of Congress for that. If you lose data, that's a big problem, and that's fundamentally what this is designed to protect against. Our system is designed to protect against. The current system, the current legacy systems, security systems, there's lots of data. You know, these logs exist. You know, Splunk kind of invented the category of log analytics, and it's been the best thing around for a long time. But you'll see that they don't take all the different log data and use it in such a way that it's left in separate silos. It's very, very hard to use standard log analytics in a security situation. It's just extremely difficult to do. The data is separated into several different databases, separate different silos. You have lots and lots of Splunk tools and 5 different third-party tools to try to analyze it. Again, I'll go into exactly the difference between classic log analytics and what we're doing. And of course, with log analytics, there's no automatic remediation. They just help you analyze the log. They don't fix anything. Said, oh, we got a problem. Okay, great. Now you got to have another completely separate system to go ahead and patch the database or patch struts or patch Linux or what have you. Splunk has nothing to do with that. They're just purely the analytic part of the problem. All right. The Oracle Management and Security Cloud, also known as the Oracle Security and Compliance Cloud. All right. This is the world's first cloud-native system. In other words, the Oracle Security and Management Cloud runs in the Oracle Cloud. Was built to run in the Oracle Cloud. But make no mistake, it doesn't manage just your Oracle Cloud assets. It doesn't just manage Fusion ERP and the Oracle Autonomous Database and assets you might acquire in the Oracle Cloud. It also manages all your Amazon assets in the Amazon Cloud. It also manages all of your on-premise assets, AIX and HPUX and those servers. So it really does, it takes the logs, takes the information, configuration information of all of your assets and unifies it, puts it in one place. Keeps track of all of your users, whether they're using Amazon, whether they're using the Oracle Cloud, whether they're using your on-premise assets, keeps track of everything. Takes all of the log data, all of that log data, unifies it in the Oracle Cloud, and then processes it with machine learning to detect normal patterns and separate normal patterns from anomalies, to try to identify threats. And you're talking about processing billions upon billions of records. And then when a threat is detected, well, again, the key thing is to find a vulnerability before there's a threat and shut off the vulnerability. Patch the system before a threat ever occurs. If there is a threat, identify the threat and take remedial action against the actor who's threatening your assets, your data assets. And you've got to be able to you've got to be able to remediate these problems in real time. You can't wait for a downtime window. Okay, so the Oracle Management Security Cloud has a unified data architecture. You'll see next slide is all the different data sources, all the stuff we put into our cloud database. Manage anyone's technology, on-premise, other clouds, our cloud. No integration required. We engineered all of these pieces to fit together. We unify the data, we analyze the data, we detect the anomalies, and we automatically remediate it. It's one system, and it's relatively easy to use, much easier to use than the other systems. Highly automated, and by the way, it integrates with your existing enterprise manager. You don't have to rip and replace all the things you have to take advantage of this. You can still have Enterprise Manager on-premise and connect it up to the Oracle and Security Management Cloud in the cloud. They will work together. One will supply information to the other. Okay, so again, your on-premise data, your public cloud data, your Amazon data, all of that data moves into the Oracle Cloud. And we have so all the data moves over, but it's, I love the expression, semantically enriched. What does that mean? It means that we add configuration data. We add, actually I have a bunch of slides on it coming up. We add plain English text to these very complex log records. You know, a Linux log has a different format than an Oracle database log. That's why this is so bloody hard for an analyst to go through, take Splunk, and look at all these different records and figure what's going on. We take all those records, reorganize them, what we call normalize them, give them similar formats, add, this is a login record. This is an asset authorization. This allows you to look at this table. This is an authorization privilege record. So we add data to make it easier for people to issue queries and analyze these log records. We also create associations, but I got a slide on that, so I'll come up. But we add a lot of information. We take the raw logs. These are the sources we take the raw logs from. And boy, that's hard, a little hard for me to read. Anyway, you know, JBoss, Linux, MongoDB. It's not just Oracle assets. Microsoft Windows. It's literally any system. Any system. We ingest these raw logs. We bring these logs over. And these are application-level systems. Application servers, database servers, MySQL, the Oracle database, SQL Server, it goes on and on and on. We take all of that information. Again, PeopleSoft application, HR applications. We take all of this information and put it into the logs. Then, we enrich the data. We enrich the data that we say that, okay, these records are associated with our general ledger. These records and these users are accessing our general ledger. And our general ledger is running on this application server. And our general ledger application is accessing this database. And all of these users are authorized to use the general ledger. It gives you this configuration information where you know that this server is running the general ledger, this application server is running the general ledger, this application server is running the database. So you can ask the question. You can ask the question, did anyone show me all the unauthorized, all the failed logins on the general ledger? Show me all the failed logins on the general ledger. You can't do anything remotely like that. Show me the failed logins on the general ledger application. By the way, I'll give you the general ledger application logins, the OS logins, the database logins associated with that GL application. You can't do that with a lot of separate logs that look entirely different. You can't ask a simple query like that. You can't automate your system. You can't, unless you have all of that configuration data. What we call associations or topology. We keep track of all that configuration data. We take the log data, we enrich it with the configuration data. We enrich it with threat intelligence. The machine learning processes all that data. This is an anomaly. This is normal. Separates the anomalies from the normal. We acquire third-party information and enrich it with third-party information. They say, these IP addresses, these URLs are bad. These are bad URLs. They're known to be associated with malware. They're known to be associated with ransomware. This server is known to be part of a robotic network designed to steal information. You can acquire all this, or these third-party data feeds. You can add your own third-party data feeds. Okay, that's this. So you can subscribe to these additional feeds. Again, certain adult sites known for putting in malware, known for putting in ransomware. When people are accessing those sites, you'd like to shut those. You probably want to shut those sites down, or make it difficult or impossible for your people to access those sites. All right. So once we've normalized the records, you can issue these plain English language-like queries. Find me all the failed logins to the GL system. Find me all the failed logins to the accounts payable system. I'm a big fan of hacking the accounts payable system. Big fan of that. I'd also like to hack our financial records because I like to invest before the announcement. I mean, when Oracle announces its earnings or someone announces their earnings, everyone finds out at the same time. How boring. I'd like to get those results a couple of days in advance. I'd like to look at that stuff. It makes me a smarter investor. Finding people trying to log into those systems, or strange IP addresses, or people browsing those databases. It's good to know, good information to know. We make it easy. This enrichment, having a real data model for all, taking all this raw log data and then attaching it to the GL system, attaching to this server, this database, allows us to do this end-to-end following of this user logged on from this IP address to this application server. We can trace the entire thing end-to-end. You can't do that with other systems, with a bunch of separate log analytic systems. Okay, and this is how many failed logins do we see for the user Mary Baker. You can do it with a very simple query. How many failed logins to our GL system from Mary Baker? How many failed logins from anyone to our GL system? These become very simple queries and things we're very interested in because certain assets are much more important than other assets. Again, I don't know if you're following all of this, but the SEC is now investigating people who are making investments that are really clever. I mean, they just seem like 40 hours before an announcement, someone, I don't want to keep picking on Ukraine. By the way, lots of great software has come out of Ukraine. WhatsApp came from Ukraine. But a lot of talented programmers and some pretty savvy investors now over in Ukraine. Okay, make it simple. Again, the Splunk thing, again, they kind of invented the log analytics category, and they do a pretty good job of log analytics, but it's very, very hard. If you have all of these separate logs, if you don't unify all the logs, if you don't enrich, if you don't normalize that data, if you don't enrich it with configuration information, if you don't enrich it with machine learning data that separates normal from abnormal, it's very hard to do your job in the Security Operations Center. And they don't have what we call an entity model. That associates these log records with a specific database on a specific server talking to a specific set of storage. They don't associate all of these users with this specific application. They don't keep track of all of the users and all of the assets because they have a lot of separate log analytics. And they don't have built-in machine learning. They don't have built-in anomaly detection. What they have is the ability for you to do your own machine learning. I mean, if you're a data scientist and a programmer, if you're both a data scientist and a programmer, you can use Splunk to investigate some of these logs, but it's very difficult. All your information's not in one place. The information is raw, very difficult to understand. And by the way, of course, they don't do remediation. They stop at the analytic phase. You want to go directly from detecting a problem to fixing a problem. They have nothing to do with remediation. It's not a connected system. All right, I got a short demo, actually a medium-length demo for our cloud security system. Again, unified end-to-end security, asset, and user monitoring. We keep track of all of our computers, all of our software systems. We know how all the pieces are connected. We understand what's called the topology of our systems. And that's going to allow us to do a much better job of detecting problems. By the way, this is the same system as used for discovering performance problems. I mean, not all problems are security problems. The same exact system is looking at end-to-end monitoring, someone coming in on a browser through this part of the network into this application server. As we trace all of that, this can be used to discover anomalies in performance and help tune the system. I'm just giving the specific example of using it to find security anomalies. But clearly, this monitoring system, keeping track of all of these assets, and we use it for just that. We use it for performance tuning. But the most important job, I think, is data theft prevention, security. So that's what I'm focusing on. It's all of your assets, all of your users, all of your databases, everything. And it's up to the machine learning software to connect the dots, to identify the threats, and then to direct the database either direct the database to patch itself, or if it's a different kind of asset, then we have to have some, run some script, which we can do to remediate an asset that cannot protect itself. Okay. One of the things you'll see in this demonstration is the kind of remediation we can do, and whether we're going to do it in an automated fashion. As I said, it's highly automated, but you decide exactly what you're going to automate with this and what you're going to let a human being decide. You can use it both ways. So you can decide that if someone's browsing from a suspicious IP address, an unusual IP address, I'm going to set the policy automatically enable multi-factor authentication. You can set up the system to do that. Multi-factor authentication, is using a combination of your cell phone and you send your password to the cell phone, and then you type it in. It's safer than just typing in your password. Password resets. You can do password resets automatically, or you could have a human being decide whether you want to do a password reset. I am going to actually demonstrate where we're just notifying an analyst about everything that the example will be an IT analyst who works for us by the name of Mary Baker getting her identity stolen, and someone breaking into our systems as Mary Baker. So it'll be an identity theft, and then all of these problems, we will detect all of these problems. We will not automatically remediate all of these problems in the demo, because if we did, the demo would be over. We're going to let Mary Baker be mischievous all the way to the end, and then we're going to shoot her down. So, but the system normally would turn the person who's posing as Mary Baker off far earlier than we're actually going to do in the demo. But the system, again, can be notify an analyst or do automated remediation. It does both. And to actually show you the demo, I have to kind of not do the automatic remediation, because, as I say, the second Mary Baker is turned off, the demo's over. Back up the slide, please. It will will also show examples of detecting a database whose configuration is abnormal. It's another thing. We'll find Mary Baker browsing from a strange IP address. We'll find a database that's abnormal. Let's keep going. We're going to do that from inside of our security operations center, where we're going to be monitoring all of the activities going on in our network. All right, it's going to be a classic cyber kill chain. It's like a spy novel. So the first thing that's going to happen is reconnaissance. Someone's going to come and start looking at our computer systems and try to figure out a way to break in. And the person's going to be, and we're going to detect that someone in a very peculiar IP address is looking around. And then the person from that peculiar IP address is going to launch a brute force attack. Just try lots of different passwords, computer-generated passwords, until they finally break in. We're going to detect that. They're going to break in. We're going to say, OK, we'll make a note of that. And then they make a lateral move. They go from breaking in, they go over to a database. They go over to a database, and they start querying all of the author. They start querying who is allowed to look at what data table. They start querying the metadata, are what is called the grants table, which in an Oracle database tells you these people are allowed to look at this data. You might want to know what users are allowed to look at our general ledger data. What users are allowed to look at our P&L, our P&L and our balance sheet, before it's been published. So next thing this person goes on is they start looking around the database and trying to figure out what users are allowed to do what, or authorized to look at what data. And then, just to cap it off, the person pretending to be Mary Baker goes to Amazon and resets some files, if you would, what I call S3 buckets, some secure Amazon files, secure to her company, rideshare, secure to her company, and decides to make those public. So what a perfect thing to do is you move the data into an Amazon S3 bucket, you change the security setting from private to public, and you're done. You've staged the data to be stolen using the Amazon system. By the way, I'm not making that up. There's a lot of stuff in the news about people who have done just that. Taken the data, moved it to an Amazon S3 bucket, marked the bucket as public, bye-bye data. All right. And okay, here comes the data. So this is our SOC, our Security Operations Center. And you can see in the last 7 days, we've processed over 9 billion new log. That one just went out. Over 9 billion new log records. But we boiled down all of that information into 2 serious threats. The threats are, we have 2 assets that are threatened, one application server and one database. And we have 1 user that's, this thing is flashing on and off, by the way. Not that anyone cares but me. And we have 1 user, Mary Baker, that's a highly suspicious user. Actually, I'm going to go over here. All right. So let's drill in. Let's drill in on Mary Baker. I am drilling in on Mary Baker, or trying. Okay, this is not working. Okay, sorry. Back up the slide, please. All right, let's drill in on Mary Baker. Okay. So now we see a series. Just check this. No. Okay, so now we see a series of 4 discrete events that occurred with Mary Baker. The leftmost event is suspicious browsing. That she came in on an IP address that we don't know anything about. And one of the things we did is we raised our awareness of that particular user. Again, I don't think this really is Mary Baker. I don't think she's moved to the Ukraine, and I don't think she's doing all this, but someone's pretending to be her, logging on a suspicious IP address. We've raised our awareness when she does that, or the person pretending to be her does that. Next thing she does, turns out that Mary Baker doesn't know her password. So she launches a brute force attack, tries thousands and thousands of passwords, and breaks in. Actually, finally successfully breaks in. The next thing she does, she goes over, looks at an authorization table, SQL authorizations table, and then finally she goes to Amazon and sets up the staging for transferring all the files over to Amazon so they can be moved to wherever they're eventually going to move to. Okay, we can drill on this. There's something called Show Details. So we can click on Show Details, and we get a little bit more information on each one of these events. But I'm going to go directly, as we drill in this. But we can get even more details by going to our threat browser. So let's go to our threat browser and take a look at this. This is the most detailed information we have. We can see the normal situation with Mary Baker. These are the normal IP addresses she normally uses when she's at home, or she's traveling for business, or she's at a restaurant. These are all things we're familiar with, and nothing terribly unusual until right at the top there, she's using an IP address and a very suspicious URL, an IP address we know nothing about. So we flag that. And then as we continue to look at that specific top event, we see that she's had several unsuccessful logons until she finally gets the password right. So what we're going to do immediately, based on this, is click on identity, and we're going to in this case I'm doing it manually. What would normally happen here in an automated system, you would automatically throw on multi-factor authentication, change your password. Do both of those things immediately upon seeing that. But I want to show you kind of that you have some discretion for this. So MFA is enabled. We've reset her password. Okay, next thing that she does, and would be the killer. This is she's gone over into the database, and she's now querying to see who in the database is allowed to see the most sensitive financial information we have. She'd like to know who those people are, what their privileges are, what their passwords are, et cetera, et cetera. Okay. We think that's probably not a good thing. She shouldn't be doing that. That's an anomalous SQL statement. Now, the interesting important point here, you could, in theory, look at every query of the grants table and just whoever does that, shut them down. Second someone tries that, just shut them down. But what if it's a test database? And you don't care. What if there are legitimate reasons for looking at this data? So you have to know the context, that this is our live financial data. This is not some test system over here. It's easy to set up a rule, saying whenever anyone queries the grants table, shut that person down automatically. You're going to get too many false positives. A lot of problems with these security systems are too many false positives, too many passwords automatically changed, too many users blocked when they shouldn't be. We do a great job of blocking the wrong users, shutting down the wrong people, and not detecting the real problems. And you've got to know context. You've got to know not that this is just a database, but what database it is, who the user is, even what time of month it is. Just how sensitive that data is. So we determine this is very sensitive data. This user, now normally we would just blow her completely out of the water at this stage. But but we go on and we look a little further. We look at the configuration. I clicked on configuration, and we find that something very strange is going on. Don't know how this happened. Interesting. But we found that the database, we got our database with all the sensitive data is drifted away from our standards. It's no longer a standard configuration. That turns out it's missing several security patches in this example. It could have its audit log turned off. One of the things people do when they break into your systems is they try to disable security. For one of the early things they do, it's not, they try to make it hard for you to figure out what's going on. Turn off logging. They turn off logging, maybe you won't notice the problems because the database isn't logging itself anymore. So they'll try to do that. You can't do that with Oracle, by the way. And by the way, and all of our passwords in the grant table are encrypted. You can't get them. But there are a lot of systems that aren't like Oracle, that have these vulnerabilities. And you better discuss, and you've got to manage them too. So, back it up one slide. So we find all of these missing patches. Very, very suspicious. Again, at this point, the system clearly has figured out there's a very bad actor pretending to be Mary Baker, and that account should be completely disabled. We need to fix this database, the Oracle Autonomous Database. Would never have let this happen. This could not have happened. But this database, whatever it is, we need to apply those patches, even if we have to take downtime. Again, the great thing about the Oracle Autonomous Database, this never could have happened. If it does happen, it fixes itself automatically. Next slide, and this is the example of her getting Amazon all ready as a getaway car to take the loot, to take the data. And what we're doing here are Cloud Access Security Broker detected this problem. As I say, we manage all of your users, all of your assets. Our cloud, Amazon's cloud, on-premise. We detect this problem. We remark the S3 buckets from public to private. We secure the data. We shut down the Mary Baker account. Disaster averted. Okay. This is very important. I mean, along with the Oracle Autonomous Database, I think this is one of the most important things we've done in a long time. This is a single system, a single complete and integrated system that keeps track of all of your assets, all of your software assets, all of your data assets, keeps track of all of your users and their behavior. It separates normal behavior from abnormal behavior. It detects normal configurations from abnormal configurations. And most importantly, it automatically remediates those problems. It is not simply an analytical system like Splunk. It is a security monitoring and management system that detects and immediately remediates the problem. Thank you all very much.